The upcoming presentation, Taking on Fake News About Climate Change, leverages material created by John Cook, founder of Skeptical Science and cognitive scientist working at the Center for Climate Change Communication at George Mason University. How do people think about climate change, and why do we need to know? The answer: not very well. Over millions of years, the human brain has evolved to avoid life-threatening dangers like predators jumping out of bushes. We survived by quickly detecting and avoiding immediate dangers. In contrast, global warming is a slow-motion disaster happening on a global scale. Our brains aren't built to respond to planetary crises stretched out over decades. So it's not really surprising that people have trouble appreciating just how dangerous climate change is. We therefore need to help people understand what obviously are inconvenient truths. Climate change can actually be summarized in just a few words. It's real, it's us, experts agree, it's bad, and there's hope. Let's take a closer look at these short statements. We don't need climate models or complicated calculations to know from observations that global warming and climate change are happening. Anything to do with snow and ice is decreasing. Anything to do with temperatures is increasing. Sea levels are rising. Species are migrating 6 kilometers poleward and 6 meters upward on average per decade. Spring is coming earlier in many parts of the world. There are many distinct fingerprints in our climate system which cannot be explained by natural causes. They, however, fit human causation. Just imagine you have a lineup with 4 usual suspects: CO2, the sun, volcanoes, and internal variability, like for example the El Niño cycles. You also have the fingerprints listed, and when you try to match them, you'll see that 3 of our suspects have alibis for most, the sun and volcanoes, or even all of the fingerprints, internal variability. They cannot be the cause. Only CO2 fits the bill, so we have our most likely culprit. Because of these fingerprints and multiple lines of evidence, there's a consensus on consensus among experts. Studies quantifying the scientific consensus that humans are causing global warming have found that it's anything between 90 and 100%, with several studies converging on 97%. So the experts agree due to the evidence. And it's not a show of hands as it looks like in this cartoon at first sight. It's more like, yes, because of the evidence, we all agree that humans are causing climate change. The consensus is not evidence of global warming. It evolved over more than 100 years from the evidence. And yes, these are cartoon versions of actual climate scientists. We also know that overall impacts are bad. Anybody living in California or Australia will be aware of the greater risk of wildfires due to global warming. Ocean acidification is making it ever more difficult for calcifying organisms to build their shells. Rising sea levels already cause nuisance flooding in parts of Florida on sunny days and will cause ever greater problems for people living and infrastructure built in coastal areas. Extreme weather events are becoming more numerous. But there's also hope. We already have much of the technology we need to solve climate change. We just have to deploy it at scale. So if things are this clear for scientists, why are we still dragging our collective feet when it comes to tackling the problem? To counter the facts we just saw, we are being bombarded with a massive wave of misinformation about climate change. Vested interests, political polarization, the global nature of climate change, as well as misinformation add up to a perfect psychological storm, preventing people from accepting the reality of climate change. The mis- and disinformers actively negate the factual statements. The 97% consensus gets, for example, pitted against the Oregon Petition Project, which tries to make you believe that more than 31,000 American scientists signing it agree with the statement that there is no convincing scientific evidence that human release of carbon dioxide, methane, or other greenhouse gases is causing or will in the foreseeable future cause catastrophic heating of the Earth's atmosphere and disruption of the Earth's climate. When people encounter both factual information and misinformation, this is what happens, as seen in a study by van der Linden and colleagues from 2017. If people only hear the fact about the overwhelming consensus among climate scientists regarding human-caused global warming, their perceived consensus increases by plus or minus 20 percentage points. If they are only exposed to misinformation like the Petition Project, their perceived consensus decreases by about 10 percentage points. And the real issue is that the misinformation completely cancels out the factual information if people are exposed to both. What can you do about that? You provide an explanation of why the Petition Project is extremely misleading. For example, many of the signatures are fake. And although 31,000 may seem like a large number, it actually represents less than 0.3% of all US science graduates, which is of course just a tiny fraction. And nearly all of the legitimate scientists have no expertise in climate science at all. They are not publishing climate scientists. If you explain to people how the petition misleads, and if you then give them the facts, the perceived consensus increases by about 12 percentage points, even if you also mention the misinformation. So the antidote to fake news is a little bit of fake news. This is comparable to getting a flu shot with an inactive strain of the virus. Recognizing this problem also provides the answer of how to respond to misinformation. We need to help people discern the difference between fact and fiction when faced with conflicting information. We can do this by explaining the techniques used to distort the facts. This is like exposing the sleight of hand behind a magician's trick. Once people see the technique behind a misleading argument, that misinformation loses its influence. This is called inoculation theory. You warn people of the threat of the misinformation, and you also give them counter-arguments and explanations of why the misinformation is wrong. An effective debunking comes with 3 elements. Start with the fact and follow the golden rule of debunking by fighting sticky myths with stickier facts. Before mentioning the misconception, proceed it with a warning to put people on guard. Finally, explain the fallacy employed by the myth. Science denial has 5 telltale techniques, and they can be summarized with the acronym FLICK. Fake experts are people who convey the appearance of expertise without possessing any actual relevant expertise. Logical fallacies are false arguments leading to an invalid conclusion. There are a number of different fallacies. Strawman and red herrings shown here are just 2 of those commonly found in denier arguments. Impossible expectations demand unrealistic standards of proof before acting on the science. Cherry picking involves focusing on select pieces of data while ignoring anything conflicting with the desired conclusion. Conspiracy theories are created when science deniers accuse the world's scientists of a massive global conspiracy. Here is a summary of the 5 characteristics of science denial. Some fallacies can be broken down further. Magnified minority is one type of fake experts, and there's also fake debate not shown on the slide. There are many logical fallacies. Let's look at some flick examples. We'll start with fake experts. By now, you are already aware of the fact that between 90 and 100% of climate experts agree that we are mostly responsible for current global warming. I also mentioned the myth that 31,000 scientists disagree with the consensus. As explained earlier, the myth relies on fake experts and a magnified minority. Just about 0.1% of signees are actively publishing climate scientists, while most of them work in other areas. There could, for example, well be some computer scientists among the signers. We know from looking at past climate change that climate is sensitive to the warming effects of CO2. I'm fairly certain that you've already come across the often heard myth that natural climate change in the past implies that current climate change is also natural. This is committing the logical fallacy of jumping to conclusions, as past climate change actually sends the opposite message than what the myth concludes. It is just as nonsensical as what the cartoon depicts. Models are based on fundamental physical principles. Nonetheless, there's an often heard myth stating that models are unreliable. It's impossible expectation to expect models to be perfect, but they are useful tools that can reproduce the past and provide insights into the future. Or, as Tom Knudsen and Robert Tullia framed it, if we had observations of the future, we obviously would trust them more than models, but unfortunately observations of the future are not available at this time. Just look at these 4 panels. One of these panels shows observed weather, as estimated by ERA interim. The other 3 show weather simulated by 3 different climate models. Can you tell which is which? I'll show you. It's the upper right-hand one, and at a guess, you'd be just as hard-pressed as myself to actually tell the difference. For the last 30 years, the sun has been getting colder as Earth has been getting warmer. Sun and climate are moving in opposite direction. Regardless of this observed fact, you often hear or read the myth that the sun, that big yellow and bright thing up in the sky, is causing global warming. This misinformation ignores human fingerprints and that sun and climate have been diverging for several decades. If you come across the myth next time, ask for the data underlying the claim, and if they produce a graphic, check which year it ends with on the x-axis. I'll just let this tweet speak for itself. So what is behind science denial? The story begins in the late 80s. 3 physicists began attacking the science, linking smoking to cancer, the reality of acid rain, the severity of the ozone hole, and global warming. In other words, any scientific evidence showing that industry was harming people's health or the environment. As political conservatives attacked the science, they had powerful allies in the fossil fuel industry. Fossil fuel companies have poured billions of dollars into groups that sell doubt and emphasize uncertainty. But let's give credit where credit is due. Climate science deniers didn't invent this strategy. They borrowed from the tobacco industry, who used the same strategies to cast doubt on the scientific research linking smoking to cancer. Never let it be said that the merchants of doubt don't recycle. Why did these scientists turn against science? The first thing people think of is money, but it turns out that the motives run deeper. They believed that markets should be free from government regulation. Even a small action like a tax on tobacco could start us down a slippery slope until the government is controlling every part of our lives. Believers in free markets dislike the implications of the science, so they deny there's a problem in the first place. The disinformation campaign has been all too effective. Over the last few decades, Americans have become more polarized about climate change. Democrats are more accepting of climate change, while Republicans are moving in the opposite direction. Climate change has become so polarized that the biggest factor driving people's attitude on climate change is not education, income, age, or gender, it's political affiliation. Unfortunately, climate change has become tribal. Is there a way to tell genuine skepticism, which is the cornerstone of scientific inquiry, from denial? Skepticism is a good thing. A genuine skeptic considers all the evidence before coming to a conclusion. Science denial, on the other hand, works in reverse. Deniers have a predetermined position. Then they deny any scientific evidence that contradicts their position. But how can we easily communicate logical fallacies without first sending people on a critical thinking course? Let's deconstruct an actual quote from Marco Rubio, one you already saw with slightly different wording. There are two premises in the statement. The climate can change through natural processes, which is true. The climate is currently changing, which is also true. Rubio then concludes that the climate is currently changing because of natural processes. This is a non sequitur, as the conclusion doesn't follow from the premises. He is jumping to conclusions. For example, Marco Rubio's logic is the same as seeing a murdered body and arguing, well, people have died of natural causes before, so this person must have died of a natural cause as well. It's an obviously ridiculous argument, but the logic is exactly the same as Marco Rubio's logic. The beauty of parallel arguments is that you don't have to walk people through a whole critical thinking course in order to see the flaw in an argument. You can debunk misinformation in a glance, with a single meme or cartoon. Here are some more examples for parallel arguments. Some of you may remember Senator James Inhofe bringing and throwing a snowball in Congress in order to disprove global warming during winter. I'll let you read them for yourself. Over the last few decades, our planet has been getting hotter, with 2016 being the hottest year on record. And it currently looks likely that 2019 will be among the 5 hottest years, all of which will then have happened in the last 5 years. But when the US withdrew from the Paris Climate Agreement, Scott Pruitt, former head of the EPA, gave a press conference in the White House and argued that global warming stopped in the 1990s. What he's doing here is the technique of cherry picking. We see the temperature goes up and down from year to year, mostly due to ocean cycles. That means that even during a period of long-term warming, you can cherry-pick short periods when it looks like global temperature is not rising. The technique of cherry-picking is like being on the bow of a sinking ship and arguing that it's not sinking because you are actually moving upwards. By not looking at the overall picture, you can come to dangerous conclusions. If you'd like to learn more about the basics of climate science and how to debunk the misinformation about that, please join our massive open online course, or MOOC, Denial 101X. It's currently still running, but only until December 17, which might be enough time to check it out, but not really enough time to work through the 6 weeks worth of lectures. We'll restart our course on February 4, 2020 with another self-paced run. We also have some additional material on skeptical science, like these very short fact myth fallacy debunkings, also featuring videos from Denial 101X. In addition, we have a slide deck featuring about 40 myths, some of which you already saw during the presentation. It's available in both English and German. I have prepared a little quiz with which you can train your fallacy spotting savvy and enjoy some more of John's cartoons. The Google form also contains a comment box you can use to ask questions or provide feedback. If you leave your name and email address, I can respond to your questions, if any. Thanks for listening, and thanks to John Cook for the presentation material and his Cranky Uncle cartoons. Here are the definitions for the quiz, and I'll just leave that slide up for the time being while you are working on the quiz.